Hello, we are starting a new chapter today over polynomials. And so this lesson is actually going to be pretty simple, pretty straightforward, so you can look forward to that. We're talking about adding and subtracting polynomials, but obviously before we can get started with how to add and subtract polynomials, we want to give you guys a little bit of information on how to describe polynomials. So the first part here we've got going on is describing polynomials, and the first kind of like vocabulary word, if you will, is this word here, monomial. And you will notice that I kind of boxed the word mono. A lot of you guys probably already know the root mono means one. And so a monomial is basically one term. And so a monomial can be a number, or it can be a variable, or it can be a product of a variable and a number, so a product of both. So I've given you some examples here of monomials. The number 7 is a monomial, it's one term. The variable z, one term. This one has a product of a number and a couple of variables, and this is all considered one term, negative 3x squared y. And we even have b over 4, and you might be thinking to yourself, but that's not a product, it looks like division. But we can write this as 1/4, the fraction 1/4 times b. So that's how we get that product there. I do want to make it very clear that even though we can have a fraction where b over 4 as a monomial, something like 4 over x would not be considered a monomial because the variable is on the bottom. In this case, the variable is on top. So it's okay to have fractions where the variable is on top, but not on the bottom. That's not considered a polynomial. And later in Algebra 2, you'll see more about these kinds of functions. But for a polynomial, the variable has to be on top. So that's some examples of monomials. And then we have degree of monomials. The degree of a monomial is basically the sum of the exponents of its variables, which is kind of interesting because when you look at this one, we'll just go backwards here. You see that I've written under here like these numbers. This is the degree. This is b to the 1 power. And that's why the degree is 1. Again, it's the sum of the exponents of its variables, and this only has one variable, so it will just be 1. In this case, you have two variables. The exponent of the x variable is 2. The exponent of the y variable is 1. And when you add those two together, you get 3. So the degree is 3. For the z, we have z to the 1 power, and the degree is 1. And the one that doesn't seem that obvious is this number 7. It's called a constant. We call a number with no variable a constant. And its degree is 0, and it might not be obvious why right away, but you will recall that if I do put a variable, like maybe an x, and I put it to the 0 power, which is the exponent, the degree here is 0. If I put it to the 0 power, we learned in the last chapter that anything to the 0 power is really just 1, and 7 times 1 is just 7. So basically, whenever you have a constant, there is no variable there, which means that the degree of the variable is 0, and that's why the degree of the monomial is 0 as well. So that just kind of gives some idea of how to do that. So now in our first example, we have find the degree of each monomial. So I'm going to go through here and just kind of show you how to do that again. 2/3 x could also be written as 2x over 3. It shouldn't scare you as a fraction. But in any rate, either way that you write it, the degree or the exponent of the variable is 1. So in this case, the degree of a is 1. Over here we have one where the exponent of the x variable is 2 and the exponent of the y variable is 3. So when I take my 2 and my 3 and add them together, I get 5. So the degree of 7x squared y cubed is 5. And then over here we have a constant that has no variable, and if it did have a variable, the exponent of that variable would be 0, and so it would be -4 times 1, which is just -4. So the exponent is 0, and so the degree is 0. And now I'd like for you to try these 4 examples in much the same way. Okay, so that was a monomial. Now we're going to get to a polynomial. And earlier we said that mono means 1. And now we have poly, and poly means many. like polygamy, when you marry more than one person, right? So poly means many. So now we're talking about many terms. So a polynomial can be one monomial, or it can be the sum or difference of two or more monomials. So basically, again, the wording can get kind of weird, but basically we see some sums, some difference, some sums there. And we see different monomials, like 3x to the fourth is one monomial, 5x squared is one monomial, 7x is one monomial, the number 1 is one monomial. But when I combine them with addition and subtraction, now I have a polynomial. So a polynomial is said to be in standard form. This is really important. A polynomial is in standard form when the degree of the monomial terms decreases from left to right. So we can see that here we have x to the fourth, and then so that's the exponent. When it talks about the monomial terms are each individual term. Okay, so the degree, so the exponent of each term, the degree is decreasing, getting smaller from left to right. So as I go from left to right, the exponents should be getting smaller. So this degree is 4, this degree is 2, this degree is 1, and this degree is 0. And you can see how they're decreasing. That is what it means to be in standard form. If it's not in standard form, then your job as a student is going to be to put them into standard form. All right, the other thing that we need to be very careful with, excuse me, while I answer the door in the middle of my video. Pardon us. Liza?
Wait, why? Thank you. Sorry.
Gracias por
Hi,
venir.
Algebra 1.
Hello, Algebra 1.
Good luck.
Hey, party.
Don't
everybody.
screw up.
All right, so the degree of a polynomial. Again, I want to be very clear with this because we just talked about over here the degree of a monomial. So I kind of want to show you the difference between the degree of a monomial and the degree of a polynomial. The degree of a polynomial is the same as the degree of the monomial with the greatest exponent. So again, if you don't understand what those words mean, it's really simple. We just said earlier that the degree of this individual term, monomial, this is called a monomial, the degree of that monomial is 4. The degree of this monomial is 2. The degree of this monomial is 1. The degree of this monomial is 0. So each monomial has its own degree. But when we talk about the degree of the polynomial is going to be the term that has the largest degree. So obviously, here's the winner. There is the term, the monomial, with the greatest exponent. So we don't say that the degree of the polynomial is 2 or 1 or 0. The degree of this polynomial is 4. Because the largest exponent is the 4. So it's kind of like the largest one takes the throne, so to speak. Okay? So that's that little guy. So now I'm going to give you guys a way to classify polynomials based on the number of terms and on the number on the degree. So we have two names. We have a name for the degree and a name for the number of terms. Okay? So I'm going to fill in this chart with you, and we're just going to get started here. Okay? First of all, degree. Remember, this is asking for the degree of the polynomials. So all of these examples that I've given you are in standard form because the degree of this is 1 and the degree of that is 0, and it's decreasing from left to right. The degree of this one is 2, 1, 0, decreasing from left to right. This one only has one term. This one has two terms. The 4 is bigger than the 1, so it's decreasing left to right. And this one is only one term, so it's decreasing from left to right. These are all in standard form, and my degree is going to be the term that has the largest exponent. So in this case, we have a 1 and a 0, so the degree is 1. In this case, we have a 2, a 1, and a 0, so the biggest one is 2, so its degree is 2. This one only has one term, so it's obviously going to be a 3. And this one, the 4 is bigger than the 1, so 4 is the degree. And this one is a constant, and we talked about that already. This one's going to be a degree of 0. Okay? So that's the degree. And then you can use, we have names for these degrees. If you have a degree of 1, you're considered to be linear. That's the name that we give you, linear. If your degree is 2, then we call you quadratic. If your degree is 3, we call you cubic. Okay? And if your degree is 4, at that point, we don't have names anymore. So at that point, you just call it 4th degree. I know it's not very fancy, but some books will call it quartic, but we're just going to say that if it's a linear, you have, the name is linear. If it's a degree of 2, it's quadratic. If it's a degree of 3, cubic. If it's 4 or higher, 4, 5, 6, 7, then you just say 4th degree, 5th degree, 6th degree, 7th degree for the name. And then of course for the 0, that one's a special one as well. We call that one a constant. Anytime that you have a 0 degree, we call that a constant term. Okay? So that's how you name the polynomial using the degree. But you can also name the polynomial by using the number of terms. How many terms are there? So in this case, you have 1 term, 2 terms. Number of terms is 2. This one has 1, 2, 3 terms. This one has 1 term. This one has 2 terms. And this one has 1 term. Okay? So we have special names for polynomials when they have a certain number of terms. So if you have 2 terms, we call that binomial. You know that bi means 2. Okay, like a bicycle is 2 wheels, right? So binomial meaning 2. 3, like a tricycle, is trinomial. The prefix tri meaning 3. And of course, we already talked about the 1. That's a monomial. And then here we have another binomial. And then we have a monomial again. Okay? So those are the names of the polynomial. So you can give each polynomial 2 names. One name based on the degree and one name based on the terms. So, for example, I would call 7x plus 4 a linear binomial. This one would be a quadratic trinomial. This is a cubic monomial. This is a 4th degree binomial. This is a constant monomial. That's what would be its name, okay? So keep that in mind and write it down in your notes so that when we get to this example, we're going to be asked to do a couple of things here. It says, write the polynomial in standard form and then name the polynomial based on its degree and the number of terms. So first thing is that this degree is 0 and this degree is 1, so they're not in the right order because it's supposed to get smaller from left to right. So the 1 should go first, so negative 2x to the 1 power plus 5. If there's no sign in front of the 5, then we assume that it's positive, so it's a plus 5. So negative 2x plus 5. This is now in standard form because this degree is 1 and that degree is 0, and it will decrease from left to right. Then we're going to go to B real quick. And in this case, because we have like terms, 2 terms that have x to the 4th in them, we want to combine those terms together first. So 5 and 3 is going to give you 8x to the 4th. And then we're going to put the 2x squared next. And then lastly, the minus 4. Remember, that has to be in standard form. So the biggest exponent has to go first, and they have to get smaller as you go from left to right. So 4, then 2, then none. Okay? So now they're both in standard form, but now we need to give them names. Okay? And because this has a degree of 1, we're going to call it linear, as per your chart. And because it has 2 terms, it's going to be a binomial. So this is a linear binomial. Over here, we have the degree is 4. So remember that once we get past 3, we don't have specific names. We're just going to call it 4th degree. And because there are 3 terms, we're going to call it a trinomial. 4th degree trinomial. All right? And that's how you do that. So now you can try these 3 examples here. Remember that the first thing you have to do is to put them in standard form and then name them based on their degree and number of terms. All right, the last couple of things that we're going to do lesson today is adding polynomials and subtracting polynomials. So here's my first example, and I like to do this in a, what they call like a vertical method. You know that we can only combine like terms, so I can combine x squareds with x squareds, but I can't combine x squareds with x cubed, or x squareds with x's by themselves. So what I like to do is to kind of rewrite the problem vertically. In other words, I know this is positive 2x squared, so I'm going to put the 2x squared underneath the 4x squared because those are like terms. The negative 9x here I'm going to put under the 6x because they're like terms. And the positive one I'm going to put under the 7 because they're like terms. And then I'm going to add them this way. So 4x squared and 2x squared is 6x squared. 6x's minus 9x's is negative 3x's. And 7 plus 1 is 8. And this is my final result. So when you're adding polynomials, it's not very complicated. All you have to do is add the like terms. So now you can try these. Excuse me. And then we will do our last example, which is subtracting polynomials. Now this one can get a little bit trickier because of this minus. When you have a plus and you distribute the plus to everything, it doesn't change the numbers. But with negatives, it does. When you and you do have to distribute the negative to everything that's inside these parentheses. So that's going to be negative times positive x cubed is going to be negative x cubed. And then you have a negative and a negative 8x squared. And that's going to become a positive 8x squared because of the negative times negative is a positive. And then this negative times this positive is going to make it a negative 11. Okay, so once I've done that, then I continue like I did before, and I'm going to put them lined up. So I'm going to want my x cubes to be underneath these x cubes. And then I'm going to want my 8x squared to be under my 8x squared. And then my negative 11, you can see my negative 11 doesn't have anywhere to go here because there's no x's here. So I'm going to put my negative 11 kind of over here. Okay, so don't want you to get confused there. The red part was from before. Okay, so then when I combine things, after I've distributed the negative, you can actually go back to addition and combine these. So 2x cubed minus x cubed is just going to be 1x cubed. 5x squared and 8x squared. This is a plus because that's positive 8x squared. 8 and 5 is 13, so 13x squared. And then since there's nothing to combine with the 3x's, I just leave the 3x's. And there's nothing to combine with the negative 11, so I leave the negative 11. Okay? And then this would be my complete answer. And out of just, review here, it's a cubic polynomial of 4 terms because it has 4 terms there. So that's how you subtract polynomials. So I just want to make sure that that's clear for you. So I'm just going to recap really quickly again what I did. It's important with subtraction that you distribute the negative. So here in the red, I've distributed the negative. Negative times positive is negative. Negative times negative is positive. Negative times positive is negative. That's the red part. Then I went ahead and I put the result of what I got here underneath the corresponding terms. And so keeping in mind that there was no x term to combine here, and there was no term to combine with the constant either. So you combine the 2 and the negative 1, you got 1, 5 and 8 and 13, but there was nothing to combine with the negative 3x, so it stayed negative 3x, and nothing to combine with the negative 11, so it stayed negative 11. Okay? So now you are going to try these examples, and once you have done that today, then you will have completed today's lesson. So have fun doing that, and thank you for watching today.